Welcome to section 1.4, Other Effective Sampling Methods. So we're going to first consider another random sampling method. It's called a stratified sample. And a stratified sample happens when we separate the population into homogeneous, so similar, non-overlapping groups, and those are called strata. And then from each group, we do a simple random sample. And so our sample has the same proportion of whatever groups as the population does. All right, so let's look at an example. Let's say that we are in a political science class, for instance, and we wanted to get the opinion of the class on some political issue. Rather than taking a simple random sample from the entire classroom and risk maybe having a different proportion of Democrats in our sample than the proportion of the actual population of the classroom, we can first divide up the classroom into the political parties . So we'll separate, let's say, Republicans. Let's say the dots are the students that are Republican. Then we can separate them into Democrats. And then the dots are the students that are Democrats. And then we'll just have like an other category, so like your independents, independent party, all that stuff. All right. So notice in how I drew the picture, we have the most Democrats, second highest population of Republicans, and then the other. So when we do our simple random sample from all groups, we can do it so our sample is proportional, similar proportions as our population. So for instance, maybe we would do 3 Republicans. We would do an SRS, simple random sample of Democrats, maybe 1, 2, 3, 4, 5 in our sample, and then just 1 independent, or other, I mean. All right, and so then this is going to be our sample. That one's going to be our sample. Okay, so some pros of this is our sample size doesn't have to be as large, because all of our stratum have similar opinions. So we don't actually need a whole bunch of Republicans because they're probably all going to have the same opinion about a political issue. We don't need as many Democrats in our sample because they're probably going to have the same opinion on a political issue. So we can sample less individuals in each stratum since it's homogeneous. That's a good thing. All right, so I'll do a happy face because that's a positive. A bad thing is we are performing a simple random sample on each group. So SRS, simple random sample. Since that is still performed, we are dependent on a frame. And that's not really a bad thing or a good thing, but what happens if we can't make a frame? Then it's definitely a bad thing because we couldn't do this method. So we'll just do a neutral face. It's kind of a neutral point. Okay, so we actually do have an effective sampling method that does not rely on a frame, and it's called a systematic sample. And essentially, how this would look in real life is, let's say we wanted to do a survey to all students that use the library at El Camino College. Well, we could get our stack of surveys and we could stand outside the library and we can give a survey to every 10th student. And that's random because it's every 10th student, it's happening by chance, and we do not need a frame. We can just count every 10 students and hand out a survey. Okay, so let's write some things down. First, we have our formal definition. A systematic sample is obtained by selecting every kth individual from the population. The first individual is a random number, is selected by looking at a random number between 1 and k. Okay, so this is very easy to employ. So it's easy to do, and it doesn't require a frame. So that's great. Okay, so again, what we were doing is we were giving a survey to every 10th student. And then let's say we chose a number between 1 and 10, and what is it? Let's say it's 6. So we could say starting with the 6th student coming out of the library. So the people we'll give the surveys to are the following. So we'll give surveys to, so we're starting with the 6th. And then after 10 students, that would be the 16th student gets a survey, then the 26th student, and then the 36th student, the 46th, etc., until we run out of surveys. Okay? And again, just to clarify, what this means is that that 6th student, that was the first person in our survey. Here's the second person in our survey, the 4th, or the 3rd, the 4th, the 5th, etc. Okay, so a couple of things. When we determine this number, when we're figuring out what number to give, or how many students, every number of students to give the survey to, so the 10th, for instance, that number has to be perfect. Because if it's too small, like if we're giving surveys to every 3rd student, we might run out of surveys and students will still keep coming out of the library, right? And we need to have everyone's opinion. Also, the people coming out of the library later on in the day might have a different opinion. So now we don't have a good sample. Likewise, if that 10th number, if it's too big, like if we looked at every 100th student, right, then we might run out of students. It might be closing time and we have a huge stack of surveys. Okay, so we want to make sure we get just the right K in this case. That's what the 10th is, it's the K. All right, so we're going to go over that by our approach to how we actually do the systematic sample. And your first step is you have to determine or estimate your sample size, your population size. And the letter we use for population size is capital N. Okay, and then based on your time and your money, so essentially your resources, you want to try to get the biggest sample size possible. So based on your resources, that determines your sample size. And then to find K, you want to essentially break up your population into n amount of pieces, little n amount of pieces. So population size by sample size. Okay, and then that's probably not going to be an integer, so let's round down. And then that's your K. That's your K. That needs to be an arrow. Okay, so you're going to divide our population size into n sample size, little chunks. And that's going to be your K after you round down. Okay, so now we generate a number between 1 and K. That's your first member of your sample. I should say random number. Everything needs to be random. That's the whole point. and we call that number P. Okay, so these are the individuals in our sample. We start with P, and then we're going to count K. So P plus K is the second member. And then we're going to add another K. And another K. All right, and so we keep adding copies of K until we get the nth member of our sample. Okay, and the pattern is this. It's P plus some multiple of K. All right, let's look at the pattern. So here, this is the first member of our sample. Here's our second, our third, our fourth, our fifth. This has to be the nth member of our sample because that's our sample size. And notice that our sample size related to the multiple of K, it's always one less. So the formula for our last sample individual is this, P plus n minus 1 times K. All right, let's look at an example. We want to predict the outcome of a county election, oh, excuse me, someone does, and the newspaper obtains a list of all of the registered voters in the county, and they want to do a systematic sample. All right, they want to use a sample size of 50. So first we have to determine the K. So we're going to, remember we have to look at population size over sample size. Okay, so here's our population divided by 50. Okay, and then we can put that in our calculator, we're going to get this. But then we have to round down. So we'll round down to 18,900. So every 18,900th voter gets a survey. So we're going to determine the individuals who will be administered the survey if we randomly chose the 27th voter to start. Okay, so we're definitely starting with 27. And then we have to add our K that we found. So we're going to add this. And then the next voter, the 18,927th voter, gets a survey. All right, and then we add a K. And now the third member of our sample is going to be the 37,827th voter. Okay, and we're going to continue this until we get the 50th voter. And the 50th voter follows our formula from before. It's our P, where we're starting, plus n minus 1. So we're going to add 49 copies of K. And K is that 18,900. All right, so this is a nice little exercise in order of operations. So put that into your calculator. And the very last voter in our sample is going to be the 926,127th voter. All right, there you go. Okay. So let's go ahead and move on to our next example of a random sample. We're looking at a cluster sample. We have to be careful because cluster sample is really similar to stratified sampling because we begin the same way. We begin by grouping the individuals from our population. All right, but what's different with the cluster sample is we just choose some of the groups and then everyone in that group comes to the party. Stratified sample, we choose a little bit from every group. So this kind of sample is handy for this situation. Let's say we wanted to take a survey of all Math 150 students. And it would be really awkward to just do a simple random sample of all students and then the administrators come into the classroom, maybe give, surveys to 5 to 10 of the students, and then the whole classroom has to wait while 5 to 10 students take a survey. All right, awkward. What would be better is if we just chose some of the Math 150 classrooms, and then everyone in that classroom got a survey. So that's exactly what a cluster sample is. So the population is divided into groups. So we kind of have these natural divisions of classrooms. So let's make all these rectangles 150 classes. We'll say there's 5, right? And then we have all the students in the classroom, something like this. Almost done with the drawing. Okay, and so this is the population. And we would do a simple random sample. Let's say these are 5 sections. So simple random sample on the sections. And then that would give us our sample. And maybe our simple random sample, we just wanted 2 classrooms. Let's say we got 2 and 5 on our simple random sample. So the 2nd and the 5th class would be part of the sample. And now everyone in those 2 sections, everyone in the 2 sections is part of the sample. All right, and there you go. All right, so let's write out that process. So again, what happened is we randomly select 2 sections of Math 150. From the 5 sections of Math 150. And then all the students from that section are in the sample. So all students from the 2 sections are part of the sample. And there you go. And that's your cluster sample. Okay, so those are the random sampling methods that we have. So here's a nice visual to help us. So first we had a simple random sample. And remember, simple random sample required a frame. And from the entire population, so no grouping, directly from the entire population, we select a few individuals randomly. Stratified sampling still requires a frame. But before we do our simple random sampling, we make homogeneous groups and then take a little from each group. We looked at the systematic sampling. This one's easy to do. Does not require a frame. Oh yeah. And it's a counting game. So in this case, every 3rd person was selected for the systematic sampling. And then finally, the cluster sample, we still do the groups. So notice we're breaking up our population into groups. And then we choose some of the groups. So in this case, it looks like we chose this group, and then everyone in the group is part of the sample. Okay, so there you go. The last thing we're going to discuss quickly is, again, a convenience sample. And a convenience sample is one in which the individuals in the sample were easily obtained, so it's not random. So again, some examples of this could be like a self-selecting survey. If you're calling into a radio show to give your opinion about something, choosing to give your opinion online for an online survey. Those are self-selecting surveys. They're not random. So we call it a convenience sample. And the problem with convenience sample is it doesn't reflect the true population. So any studies that use this type of sampling have results that are suspect. Results should be looked upon with extreme skepticism. Okay, so we go through a lot of care to make sure our samples are random. Samples that are not random, convenient samples, the results are almost useless. You can't really trust them.